Welcome back for one last installment for section 17 in geometry. We'd like to take a look at one more theorem, and it's presented slightly differently than others have been, just in that it shares the given and it has the proof statement. So it's a little bit different. It seems more like one of the homework problems. So let's say we have triangle ABC. Okay, triangle ABC. Let's take a look at triangle ABC. Yep, that looks good to me. ABC. Let's let M and N be the midpoints of the two sides, or of two sides of the triangle. So let's grab our ability to draw a polygon here. Excellent. So here's our polygon, and I'd like to add a couple of midpoints here. So let's a midpoint for this side and a midpoint for that side, and move them onto the actual sides here. That looks pretty good. And then what I'd like to do from here, this looks a bit like an isosceles triangle, and it doesn't have to be just any triangle. And then we want to say that, right, so if we have this situation, M and N, we want to say that the line passing through M and N, this guy, is parallel to the line BC. Oh, because I mislabeled them. I did it slightly backwards. Let's relabel these so that way it matches what I have drawn. Let's put A at the top. So it didn't change our midpoints here. I just swapped where A and B are. So now it's parallel to BC. There we go. That looks much better. All right, so MN and BC. Well, I guess it would have changed. That N should have been over here. Anyway, doesn't matter. Fixed it. Got it right now. We have triangle ABC, midpoints M and N. The line passing through M and N is parallel to BC. Furthermore, the distance from M to N is 1/2 of the distance from B to C. And this seems a little bit weird. Yeah, it really seems a little strange. So let's take a look at what we're trying to say here. We're trying to say that the line passing through M and N is parallel to BC. So this line and that line are parallel. And that this distance is 1/2 that distance. And what we want to do is we want to construct, in order to prove this, we want to construct a parallelogram. So the first thing that we're going to do is we're actually going to make a line that's parallel to AB. So let's say we have a line that's parallel to AB. Looks something like that. And then let's say that those two lines cross at some point E. Well, because we have that N is the midpoint, we have that this side and this side are congruent to one another. So that gives us congruent sides. We could also notice that we have a pair of vertical angles here. So that gives us congruent angles. And then we have this line here, right? The line through M and N is a transversal of the parallel lines AB and let's call it L. So that tells us that this angle and this angle, angle 1 and angle 2, are congruent to one another. So with that, we have side angle angle. and that's fantastic. We could also look at it as AC is a transversal of parallel lines AB and L. So we could also say that angles 3 and 4 are congruent to one another, in which case we'd still have side angle angle. So we can get that these two triangles are congruent, which tells us that this side and that side are the same length, okay? Because we would have, because of the way that they are congruent to one another. So this side is congruent to this side because M is the midpoint, and that gives us that it's congruent to that. So that tells us that this quadrilateral has a pair of parallel congruent sides. And by theorem 17.3, we have that BMEC is a parallelogram. So that immediately gets us that MN is parallel to BC. From there, we just have to show that this distance is half of this distance. But we get that because this side and this side are congruent. So that length plus that length is this length. And that immediately gives us that this is half the length of that. All right, so I just said to you what the proof is. We're going to go ahead and write it down. So first, the givens. Of course, we have triangle ABC. And from that, we're going to say that M is the midpoint of AB. M is the midpoint of AB. And we're going to say that N is the midpoint of AC. N is the midpoint of AC. Excellent. These are the givens. All right, the next thing we did was we constructed this line L. So there exists, oops, should be a backwards E here for exists. There exists a line L, which is parallel to a B, and it is through the point C. Okay, we made it so that way it passed through C. And that's given by the parallel existence theorem. Okay, so we found L. Of course, we have that the line passing through M and N intersect L because a line that passes through one parallel must pass through the other parallel, right? So that is the next thing we want to say, that MN must intersect L. And we've labeled that point E. So that's by the transversal of parallels theorem. All right, once we had that, we noted that there were some congruent angles. So 1 and 2 are congruent, and 3 and 4 are congruent. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Excellent. And that's given by the converse of the alternating interior angles theorem. We could write that as the converse of the alternating interior angles theorem. I believe that's how we wrote it in the past. All right, so once we had that, we also needed to note that the length from A to N is equal to the length from N to C because N is the midpoint of AC. So that gives us that AN is equal to NC because N is the midpoint. So this is just simply by the definition of midpoint. All right. So what did that give for us? That gave us that we have congruent triangles, and we want to name them and say the congruence appropriately so we can really emphasize what exactly is congruent. So we would say that triangle ANM triangle ANM is congruent to, right, we want to match these up appropriately. So angle 3, angle 4, and then we're passing through the congruent sides. So CNE in this case, congruent to triangle CNE. And that's given by angle, angle, side. And what are the angles? Well, we said that angle 1 and 2 are congruent, and then angle 3 and 4 are congruent, and then the sides, right, angle, angle, side, the side were these two sides. So the first angle was given in 4A, the second angle was given in 4B, and the sides, equal length sides, was given in 5. So we should make sure that we're clear to specify that angle, angle, side came from here, here, and here, angle, angle, side. All right, so we have congruent triangles. Well, what did that tell us? That told us that CE is equal to AM. So CE is equal to AM. That gets us this side here. But we also have that MN is equal to NE. Excellent. And this is because of the definition of congruent triangles. All right. So once we have that, right, we don't use both of these together at the same time, but we will need both of them. The first one that we're going to use is that EC is then equal to MB. EC is equal to MB. Oh, let's see here. I have it somewhere. Where did these equalities go? EC, that's CE, so that's this guy, and I want to connect it to MB. Did I forget to? Hold on 1 second for me. All right, I apologize. We're saying that this is because of the transitive property of equality, because now we could call this CE is equal to MB because we have that AM is equal to MB, but we never actually said that part. We have that CE is equal to AM because of the congruent triangles, and we have that AM is congruent to MB because of the definition of a midpoint. So it's because of the transitive property of equality, even though I didn't specify that explicitly here. It might not be a bad idea to have done that, so I apologize. All right. So once we have that, we have a pair of congruent parallel sides, right? Parallel and congruent, as we say right here. So we have that BMEC is a parallelogram. And that's by Theorem 17.3, part E, that we're taking a look at there. If we go back to that, part E says a pair of opposite sides are parallel and congruent. Then we have a parallelogram. So that's what we're taking from that. The next step, once we have that ME is equal to BC because it's a parallelogram. Or by that same theorem again. ME is equal to BC, again by Theorem 17.3, right? The two pairs of opposite congruent sides. So that was by part B. All right, we have that N is the midpoint of ME, and that's simply by the definition, right? We have that, see, we specified it somewhere along in here. MN is equal to NE. So by the definition of a midpoint, N is the midpoint of ME. And then the next step is to recognize that MN is 1/2 of that. And that's again by the definition of midpoint. So that gives me that, let's see here, MN is equal to 1/2 of BC, right? This distance is 1/2 of BC because we said that ME is equal to BC, so we can just make that substitution. Right, we said that ME is equal to BC, so we make that substitution. And finally, so we have that it is, the distance is 1/2, but we also need to state that it is, that the two lines are parallel. And we have that this and this are parallel, hence MN and BC are parallel. So we've had that for a while, we just haven't stated it yet. So MN is parallel to BC. We already said that it is a parallelogram, so those are parallel by the definition of parallelogram. And that's it. Excellent. There is a question regarding the use of GeoGebra. So I'll create a brief video on GeoGebra as well, which you can use for this homework and any other homeworks that utilize GeoGebra. So thank you for your time. I'll see you guys in just a few minutes. Well, I suppose it'll be longer than a few minutes, whenever it is you come and watch another video or meet with me in class. Anyway, I'll see you guys later.